Hi, previously we looked at how to expand quadratics, and now I'm going to show you the opposite process, which is called factorising. And to do this, we're going to use our knowledge on expanding, and I'm going to ask you to design an expanding question that equals this. So if you weren't completely fluent at expanding, it's probably better to practice those skills before you move on to this. So if you like, pause the video and see if you can make an expanding question, and then play it when you think you've got one. So this is how I'm going to explain it to you. So most of you probably use the grid method to expand quadratics, and if you think about it, if this is the answer, we know there's going to be an x squared here, and we also know that this term features down here. And at this point we can start to fill in some of the edges. So to make an x squared, from before we had an x there and an x here, and then we had a number here and a number here that multiplied together to make 12. The problem comes when I use these numbers, it will also create these two cells, and these two cells, when we collect them together, must equal 7. Now these two numbers we call factor pairs of 12. So I'm going to start by writing some down. So if we write down 1 and 12, and let's pop them in and see what happens. So here I have 12x's, and here I would have 1 times x, so 1x. If I collect those together, do I get this middle term here? No. So this can't be the right answer. Let's try another pair. So if we try 2 and 6, because 2 and 6 makes 12, pop them on. 2 times x, 2x, and we would have 6x. Again, they do not make this middle term, so we've got to keep going. 3 times 4, pop those on. 4x and 3x. We have it. Here we have 7x if we combine these two terms together. Now we can just go right to the start of our expanding. So this is the first bracket, and this is the second bracket. And that actually doesn't matter. You can pop the brackets around the other way. You could write x plus 3 first, and then x plus 4. It's completely up to you. But if you're asked to factorise fully this expression, this is the answer. Now, I personally don't like this way of doing it. I think it's too complicated. So I'm going to show you a slightly easier way. Same question. And we know it's going to be like this. We know it's a double bracket factorising. And in the next video, or a couple after this, I'm going to explain exactly why I know this. Now, we know it's going to be an x and an x to make this x squared. And we know that we then have to look at this number here, 12, and start to write down the factor pairs of it. So just like last time, these are all the factor pairs, but I'm going to encourage you to write them all down right from the word go. Now what we're going to look at is look at this pair, or this pair, and see which one I can make 7. We can't look at the 3 from here and the 12 from here. We can't mix and match the pairs. We just use this and this, or this one and this one, or this one and this one to make the 7. So you should be able to see I can make the 7 out of 3 and 4 by adding these two together. So I'm going to pop the 3 and the 4 in there. I'll just repeat that last bit. How can I make the 7 using a 3 and a 4? I need to add them both, so therefore they must both be positive, so therefore the signs here are both positive. Now it's imperative you don't finish here, you expand it. Whichever method you want, I'm going to use the lines. So x squared, 4x and 3x will give me 7x, and 3 times 4 will give me 12, so I know I'm right. If you prefer not to use this method and use the grid, the box, then do so, but always check that your answer is the question. And like I said, this is still the same answer, just pop the brackets around the other way, it makes no difference. Let's try another one. I've kept 12 on the end, so that's why the factor pairs are still here. But this time I've made the middle number 8. So which of these can I now make an 8 from? Well, 6 and 2 obviously. So let's pop those over there. How do I make an 8 at using 6 and 2? Well, I have to add 2 and add 6 will make 8. And there we have it. Expand it to check, but I promise you that one will work. Now it gets a bit trickier. So, brackets with x in. Look at the constant term, the number without an x. It doesn't have to be at the end, but 9 times out of 10 it is. And write down the factor pairs of it. Now 5's prime, so it's only one option, 1 times 5. So, how do I make a negative 6 using these? So, be really careful here. So if we add them, we get 6. If we take these away, we can get 4. If I do 5 take away 1, or I'd also get minus 4 if I did 1 take away 5. But if I put a minus here and a minus here, because that's the only 4 options I have, minus 1 minus another 5 would actually give me minus 6. So that is the answer. But remember, expand it. Here we go. Minus 5x minus 1x is minus 6x's. When I multiply this last 2 terms, I get a positive 5. I'll show you one more. So x in the front, factors of 15. This isn't prime, so we've got a few more options. So we've got 1 and 15 and 3 and 5. So which of these pairs can I make a positive 2 from? Can I make a 2 out of here? No, but you should be able to see you can make a 2 using these two numbers. So let's pop the 5 and the 3 in. Again, it doesn't matter which order. But how do I make a positive 2? Well, if I start with a 5 and I take away 3, that would give me 2. So the 5 must be a positive and the 3 must be a negative. Expand it to check it works. So hopefully that makes sense. Now it's time for you to practice, and good luck.